Alright, in today's video, we are going to use the pigz to compress file faster on Linux platform. So traditionally on Linux, we typically use gzip to compress file. And like gzip and zip, it's single threaded, and therefore typically it is slow. So the pigz stands for parallel implementation of gzip, pigz. Some say it is called pigz or pigz or pigz, either way, okay? So in this demo, we're going to use a relatively large file to demo how fast the pigz compared to gzip, okay? Also, we have another demonstration use create a table against the directory. And so let's get started. So in this directory, I have a file. It is the line item from TPCH. It's kind of a real world data. So you can see it's about 1.2 gig. And the total about 10 million rows, okay? So let's take a look at how, yeah, it's about 10 million rows and 1.2 gig size. So now let's use the traditional method to compress it, okay? So I'm gonna invoke the gzip. So this is the traditional to compress a file. So I'm gonna compress this line item table, and it's gonna take like a little over 1 minute. So let me use top to monitoring the system. So you can see for this machine I have 8 CPUs. This is a laptop Windows machine, and the VM is a Linux VM, okay? Use the VM software to simulate to create the Linux VM. So you can see only one CPU is highly being used, right? And that is why we typically see this is single-threaded, okay? So from the name, we already know the pigz. It is basically similar to the gzip. It is like enhanced edition, like used parallel implementations, okay? So it is typically on the server, you will have multiple CPUs. So you can leverage the multi-CPU and to accomplish the compress. However, in case you don't want to use all the CPUs, you could choose a set of CPUs. For example, in my case, I have 8. I can choose 8, 4, 6, whatever CPU you would like. You leave some for other process. So, all right, the first example is it is about 1 minute 35 seconds. Okay, so let's take a look at the size of the compressed file. So it's about 360, okay, megabytes. And so in order to compare with the pigz, let's uncompress it. So I'm gonna uncompress this uncompressed is typically faster, probably like 20 seconds-ish, okay? So also you can see uncompressed is typically also single-threaded, okay? So yes, 16, 17 seconds, okay? So now let's use the pigz, okay? So I'm gonna use pigz to compress this one, pigz, okay? pigz, okay? Or pigz, whichever we want to call, okay? But pigz is easy to see, okay? So if you look at the upper pane, you see all 8 CPU is being utilized for the compression. It takes like 17 seconds. So you can compare about 17 seconds versus 1 minute 35 seconds. You can see it is about 4 times, maybe 5 times faster, typically like 4 times faster for this single. However, if you use the pigz to uncompress it, it won't see this parallel. So because this mainly this program is being created to do the compress parallel, not uncompress. You see, when I do the uncompress, it's still single-threaded. Okay, so this pigz is similar like the g-unzip. Okay, so these two is similar as uncompressed, okay, and non-parallel. So let's take a look at the size. It's already uncompressed, so it's basically 360 60 megabyte. Yeah, so that is the compressed size. Uncompressed is 1.2 gig. Okay, so you can see use the pigz can substantially increase the compressed time. Okay. So the second example, I'm going to use a directory. So I'm going to use a Oracle directory for example. So I'm going to cd to the Oracle product, cd to the, so let's see. I'm planning to use, let's see, this one, RDBMS to use example. So let me remove this. So what I'm going to do is first I'm going to run the tar zcvf. So I'm going to create a tar file called let me put into the /temp, okay, called rdbms rdbms.tardz. For example, this is the traditional way to we create a tarball, use tar combined with the zip, gzip or zip, whatever the compress method being combined with the tar command. And the directory is rdbms. So we'll see how long it takes, okay? So you see it's going to compress a tons of files. And I probably can remove this, the -v verbose, right? So we can see the how long it takes to compress it's about 22 seconds, okay? So we're gonna do the same thing, but this time we're going to use the pigz, okay? To invoke pigz, we're going to use capital I, then followed by the program. So it's pigz, then minus this one. So we're going to do the same thing. The only thing difference it is previously we used the minus z that is come with the tar program. Now we invoke the pigz, okay? So we're going to do the same thing. You can see the difference. Also, you can see on the upper. So it is been 4 seconds versus I don't remember the time. Okay, probably. Let's use remove those minus v. Do it one more time. Okay. So I'm going to remove this v flag. Do a test. You see here, it's because some data already cached in the memory, that's why it's fast. But you can see here, it's parallel. So we'll do the same thing, but this time we remove the v flag. Okay, so let's do the similar thing. Of course, this is going to be faster than first time because of the caching. Okay, so still you will see the difference using this single threaded. So it's like 12 seconds versus 2 seconds. So if we're dealing with large files like 100 gigs, few hundred gigs, so this is going to give us a tremendous saving. If you need to learn more about this, the pigz, there's many options. You can currently we use the default. You can choose like how fast you want. Like by default, the flag is -6, so you can depend on your need. You can increase to this value to get a better performance, either faster or you want to try it out. But typically, in this way we just use the default option, and also as I said, you can choose also different. Let's go back to the first example. So you can use different number of thread. Okay, so let's do that. So let's do this. Okay. So what I'm going to do is use time pigz, okay, pigz. So let's see, minus p, that is the number of processor you're gonna invoke, okay? So see, I want to use 6 process, okay? So I'm gonna do this. Let's take a look. So on the top, it's not refresh. Something crashed. Oh yeah. So now you see. Let me restart this one. Somehow it's not functioning. Okay. Let's see. You see, it is 6 process is being utilized. Okay. So similar thing if let's see we use a 4 process, because sometimes you don't want to. Oh, I need to uncompress first. Okay. So let's uncompress this first. No, uncompress. So uncompress. And you can choose the number of thread or called CPUs to do this. All right, so let's give a quick summary. So we do notice when you have multiple CPU machine, right? That is typically a physical server, and you can invoke those pigz to considerably increase the compress time. Okay, so that is the tip for today.